Alright, we're going to look at markups and discount problems. First we're going to start with markups, and there's a formula we can use. This formula looks like this: S equals C plus R times C. And what these variables stand for: S stands for the selling price, C stands for the original cost for the seller, and R is the rate of the markup. And when you put that value in, normally it will be given as a percent, or you'll reply as a percent, but when you actually do your calculations, we typically put it into a decimal form. So notice there are three types of variables here, so we will have three different types of questions. You will know the selling price and the original cost, but not the rate, or you'll know the selling price and the rate, but not the original cost, or alternatively, you'll know the original cost and the rate, but not the selling price. So let's look at examples of each one of those, see how they set up. So a shirt costs a store $4 and is marked up 350%. Find the price that the store sells the shirt at. That may seem like a lot, but it actually isn't a lot in the real world, a 350% markup. So we're looking at markups, so we're looking at this formula. So let's figure out what we already know. We know the original cost for the shirt was $4, and we know the rate it's being marked up is 350%. What we don't know is how much is it selling for. So I'm just going to put that information over here. Again, 350% would translate to 3.50 as a decimal. And I'm just going to fill in those values into the formula. So I'm going to change both seats to 4. I'm going to change the 350 or the R to 350. And now we'll notice S is already by itself, so we just have to calculate this. So 3.50 times 4 gives us 14. 4 plus 14, $18 is what they sell the shirt for. Ooh, that should be an and. An online merchant marks up a television 80%. If the merchant is selling the television for $270, what was the original cost of the television for the merchant? So again, looking at markups, marked up 80%. So what do we know? Well, we know the selling price was $270. We know the markup rate was 80%. What we don't know is what was the original cost. So we're going to fill in, and again, we turn the 80% to 0.80. We're going to fill these in. So 270 equals C plus 0.80 C, and then we're going to simplify this a little bit. Notice we have C and C on that side, so we get 1.8 C. Now why is that? Well, the coefficient of the first C is a 1. So it's 1 plus 0.80, which is the same as 1 plus 0.8, 1.8. And now to get C by itself, we're going to get rid of that coefficient, so we're going to divide both sides by 1.8. And we will get the original cost was $150. A seller purchases a DVD for $2 and sells it for $10. What is the markup rate as a percent? So they purchased it, it cost them $2 originally, they sold it for $10. So we want to know what's the markup rate. So again, we're talking about markups. So selling it for $10, bought it for $2, what's the rate? And so again, we're just going to fill in these numbers and clean this up a little bit. R times 2 is the same as 2R. And now we just have to solve for R. So we're going to subtract 2 from both sides, get rid of the constant. And then to get rid of the coefficient, we'll divide both sides by positive 2. And we'll get 4, which, remember, we're talking about a rate. Rates are usually referred to as percentages, so 4 is the same as 400%. So this is a 400% markup. So those are the three basic setups for problems dealing with markups. The other groups of problems we're going to look at are discounts. So the discount formula, very similar to the markup formula. The difference here is, one, we're using capital R's instead of C's, but also we're subtracting off. And when you think about it, that makes sense. Markups, you're adding extra costs on. Discounts, you're removing part of the cost. So again, S is now the sale price of the item. Capital R is the regular price. And be very careful you keep your notation clear. Don't flip-flop little r and capital R as you're doing these problems. and then lowercase r is the rate. Again, usually you give answers as percentage, or they'll give you percentages, but when you actually do your work, you're going to use a decimal for those. So let's look at some problems. A jacket that normally costs $150 is on sale for 30% off. What is the sale price? So we go to our formula, we figure out what we know. We know the regular price is $150, we know the rate of the discount is 30%, and we don't know what the sale price is. And again, 30% converts over to 0.30 as a decimal. So we're just going to fill those numbers into our formula. Notice the sale price is already by itself. All we have to do is calculate the right-hand side. So take 0.30 times 150, get 45. 150 minus 45, 105 is what the price jacket is on sale for. The fitness supplier is having a clearance sale where all items are 60% off. Max buys a weight set for $140. What was the weight set's regular price? So he got it for 60% off. All the items are 60% off. So that means this weight set was 60% off. So we're looking at a sale, discount. So we don't know what the regular price is. We do know what the sale price is, $140, and we do know the rate. And again, change 60% into 0.60. So we're going to fill in what we know. And then we're going to combine like terms. Just like with the markups, the coefficient of that first r is 1. So 1 minus 0.60 is 0.4 or 0.40. And now to get r by itself, divide both sides by that coefficient of 0.4. And that gives us the regular price was $350. So they got it for $210 off. Normally costs $350. A computer that normally costs $1,200 is on sale for $810. What is the rate of the discount? What portion are you saving? So we're going to go to our formula again. We know the regular cost, that's $1,200. We know the sale price is $810. So what we need to do is figure out what is this rate? What is this lowercase r? So we're going to fill in what we know. And now we're just going to solve this problem. So cleaning it up a little, again, r times 1,200 is just 1,200r. So I need to get rid of that constant value. So subtract 1,200 from both sides to get rid of the constant. And now to get rid of the coefficient, we're going to divide both sides by negative 1,200. Make sure you didn't lose that negative sign on the 1,200r when we did that first step. And then we divide, and we get 0.325, which translates into a 32.5% discount. Now, if there are alternative ways of calculating these, and I'm going to show you these, but I would recommend, if you're not really confident in your abilities to do these problems, do not watch the rest of this video. Instead, stop here, rewind it, and go over those problems while you're working on your homework. So for those people that feel confident about their abilities, let's show you some alternative approaches to solving these. So let's look at that first problem again. And this time, instead of using the markup formula, I'm just going to use the standard percent formula. Percent times base equals value. Whenever you're trying to think about what's the base in these problems, keep in mind the base is always the oldest value. So what the store purchased it for. Or when you talk about discounts, how much did it cost originally? That's what the base is always. It's always the original value. Whether you know the original value or not, it's always the original value. So in here we know the original base value is $4. We know it was marked up 350%. We're going to find the selling price. So when I put these numbers in my formula, it's going to look like this. 4.50 times 4 equals X. Now, whoa, I thought the markup was 350%. It is. But you have to think about, where was it marked up from? And the answer is it was marked up from 100%. The original price is 100% of the original price. So when you mark it up 350%, then you're actually ending up at 450% of that original price. Multiplying those together, we get $18, which is the exact same answer we got the first time. Let's look at this problem. An online merchant marks up a television percent. The merchant is selling it for $270. What's the original cost? Now notice we don't know the original cost. The base is always the original. It's always the older value. So even if we don't know it, it's still the older value. That's where we're going to put our X. And again, since it was marked up 80%, we started at 100%. So now we're at 180%. Divide both sides by 180, and we get this original price was $150. A seller purchased a used DVD for $2, sells it for $10. What's the markup rate? So again, the original for this seller, the original price was $2. What they sold for it later was $10, so the base is 2. So 2 times X, 2X. So divide both sides by 2, and you get X equals 5, or 500%, which means the markup was 400% because, again, you start at 100%. So take that off of the 500, you increase 400%. This also works for discount problems. So let's look at some discount problems. A jacket that normally costs $150 is on sale for 30% off. What is the sale price? So again, percent times base equals value. The original, the normal cost is the base. And we know the discount rate, the percent. So we're going to figure out the value. Notice I put 0.70 here instead of 30%, 0.30. Why? Now we're looking at sales or discounts. In this case, you're taking 30% off of that original price, off of that 100%. So in other words, if it's 30% off, you still have to pay 70%. Multiplying those values together, we find out it costs $105 for the sale price. Exactly like we got before. A fitness supplier is having a clearance sale. All items are 60% off. Max buys the weight set for $140. What was the weight set's regular price? So again, what was the regular price would be the base value. We don't know that. So we're going to put our X value where the base goes. 60% off means we still have to pay 40%. So 40% of what is 140? Divide both sides by 0.40, and you get $350, the original price of the item. And then the last problem, computer normally costs $1,200, is on sale for $810. What is the rate of the discount? Originally, normal cost is the base. That's the older value. So the base is $1,200. The later value is $810. What's the percent? Divide both sides by 1,200, and you get X equals 67.675, which is 67.5%, which means our answer is 32.5%, because this is, you're still paying 67.5%, which means you saved 32.5%. That's how much the discount is. So you can see in both methods you're doing subtraction or you're doing addition, but in this way you're doing it more on your own terms versus using the formula. The formulas kind of protect you, walk you through it, those original formulas. So you can do it either way, it's up to you, but be careful if you do it this way. You understand base is always older value. Even if you don't know it, it's always older value.